Now, let us try to understand this object psi mu of sigma alpha. Okay, these are in general, when you do quantum field theory in 4 dimensions, they are Dirac spinors, and Dirac spinors are 4-component spinors. Okay. However, here we are working, we have a 2-dimensional worldsheet, and in this, in this case, it would be a 2-dimensional super worldsheet. Okay, because we would introduce bosons as well as fermions into our theory, and so here they are Majorana spinors. And these Majorana spinors, they are 2-component. 2-component spinors. They are 2-component spinors, and we will find that these components, these Majorana spinors are also real. So they would be 2-component spinors with real components. We will also find that these spinors, they would also be at the same time Bailey spinors. Bailey spinors are the spinors with definite chirality. Okay, so positive or negative. And in this case, the psi mu is Majorana as well as Bailey. It's a Majorana spinor as well as a Bailey spinor. Okay. So now, if it's a Majorana spinor, if I drop the sigma alpha for the time being, I can denote it by the components, or I could write psi mu A, where A takes values plus and minus. So I can have psi mu A, my precisely psi mu of minus, psi mu of plus, and not only that, when we would eventually consider the theory in the light front, you will find that one of them is a left mover and one of them is a right mover. So for example, here I would have psi mu minus, this would be plus, so this would be, you will see that it depends only on sigma plus. Sigma plus is tau plus sigma, so it's a left mover. Okay. So you will find that all these things they will follow and they are related. Okay. So we go step by step, but we will see that eventually one of them would be a right mover, one of them would be left mover. Anything that depends only and only on sigma minus, which is tau minus sigma, could be interpreted as a wave moving to the left, and this depends on sigma plus, so this is a wave moving to the right. Okay, so at the moment we can forget about this, but we remember that it consists of 2 components, and now we have to see that these both of them are real also. Okay. So now let me write down so that we know what we are talking about. Our theory is defined by the SV part, which is minus 2 by 2 t by 2 d2 sigma times del alpha x mu del alpha x mu. So this is your conformally gauge fixed polyacoustics. This is our standard conformally gauge fixed polyacoustics action, and alpha goes from 0 to 1, alpha goes from 0 to 1, or it goes plus and minus, and mu goes from 0, 1, that is to I. Here I goes from 2, 3 up to 9, because we are going to consider this for a purely bosonic theory, this would go up to 25. But for a combination of the two, the superstring theory, this will go up to 9. And this could also be, if we like, split into plus, minus, and I component, where I goes from this to this. And we have another piece as F, which is equal to minus d by 2 d2 sigma times psi mu bar rho alpha del alpha and psi. Okay, so okay, so you see here this x mu and psi mu both are our total action of the theory. I would call it R and S. This is defined as the sum of SB plus SF, and here up to 9 or plus minus up to 9. Okay, and alpha 0 to 1 or plus and minus. Okay, so when we are taking the action of our theory is defined by a sum of SV and S, both of them, this plus this. In that case, mu goes only from up to 9. Okay? So its dimension 10. Okay, we will see the consistency when you see, as usual in the case of bosonic string theory, we had eventually considered the Virasoro operators, Virasoro algebra, and then we talked about the L0 and L0 bar, and you asked or you imposed on your theory that Virasoro constraints, they annihilate the physical states. Okay, and there you derived that L0 minus A annihilated the physical states. You will have similar conditions here, Virasoro algebra and Virasoro constraints, and this eventually this normal ordering operator, it turned out to be A equal to, it was related to the number of dimensions of the theory, right? I think it was d by 24 or minus, it was probably d by 12. So 2, if I, here it would be different, okay? So minus 2 by 24, 2 by 24, and this d, when you take as 26, 26 minus 2 is 24 by 24 is 1, and so this turned out to be A equals to 1. And this was the normal ordering constant in the theory. And similarly, you will have similar considerations, and in this case, D will turn out to be 10. Okay. So now we have to understand all these pieces, psi mu bar, and the row matrices. Okay, they are the Dirac matrices, but in 2 dimensions, because our word sheet is 2-dimensional. Okay. So let me still continue to have this here for some time, and so let me remove this SB from here, and let me just make this, and plus this thing is 1 psi mu bar rho alpha del alpha psi mu bar. So that defines the action of our theory, and this is the RNS, the action corresponding to the RNS superstring formula. Okay. Now this you see this psi mu, they are fermionic and they are Grassmann barrier.